Sorry about that. Hopefully, I'm recording again because I got interrupted. Um, please bear with me. So this is gonna be -16. Did I put? I'm sorry. This is -100. This is why I got the I. It's because my calculator doesn't accept negative values. It gives me an error unless I have to put special my special settings. But sorry for that. It's gonna be -100, so it's just gonna be 10i, the imaginary number. And also for this one, it's gonna be -16. So for this one, it's gonna be 2 plus and minus. This is gonna be 4i. And this is gonna be 2, and then we're gonna divide it. So it's 2 plus and minus. I'm sorry. You're gonna divide it, so it's gonna be 1 plus and minus 2i. And this is our other eigenvalue. Okay, so we got these two of our eigenvalues, and then now we're gonna try to, now that we have our eigenvalues, we're gonna try to find our eigenvectors. Okay, so to find our eigenvectors, we're gonna use, let's start off with this one, the 1 plus and minus 2i. Let's start with this one, but instead of the minus, we're gonna use the plus only. It will make our lives easier, I believe so. So we have to plug in them on the in our matrix, which is a minus, sorry, oh my god, a minus the value of I, our identity. So it's gonna be 1 minus 1 plus 2i is gonna be 5, 0, 0, and then -5, and then 1 minus 1 plus 2i, 0, 0, and then it's gonna be 0, 0, and then 1 minus 1 plus 2y. Oh my god. And then no, not 0, this is 2. Then 0, 0, this will be -2, and then 1 minus 1 minus 2i. Okay. Now this is our equation, right? What that we have, and we're gonna equal it to 0. So we are able to find our eigenvectors. Okay. So from this, by adding this, give me a second. We're going to be able to have -2i, 5, 0, 0. And since pretty much all of them are the same, so pretty much the rest are -2i. And this is 0, 0. This is going to be 0, 0, -2i, 2. Then 0, 0, -2, -2i. And then this is going to be equal to 0, 0, 0, 0. Okay. Now from there, we're going to find the equations. We're going to try to find x1, x2, x3, and x4. So for the first equation, right, this one is going to be -2i x1. And then it's going to be -5 x2 equals x0. That's for the first one. Now for the second one, it's going to be 5 x1 minus 2y x2 equals 0. Now for the third one, it's going to be negative 2i x3, excuse me, minus 2 x4 equals 0. And then for this one, it's gonna be, I'm so sorry. For this one, it's gonna be 2 x3 minus 2i x4 equals to 0. Okay. Now let's simplify it. Now for this one, to find x, x1, this is gonna be 5 pi divided by 2 x1. I'm sorry. So I'm moving this over here. It's positive 5, and then we divide it by this. So this is going to be x1 equals this. This is x2. And then for the other equation, hopefully I'm doing it right. For this equation, it's going to be x1 equals 2i over 5. Okay. Now for these two, since they're equal to each other, pretty much I'll say this is pretty much 0 or 1. But for the one now, I'm just gonna call them, well, the reason I'm gonna call them 0 is because they're pretty much the same equation if you move it around. So x1 equals 0 and then x2 equals 0. And then for this ones, now let's do x of 3 and x of 4. So I'm going to be moving around negative 2x4 over here. This will be positive, and then we're going to divide it by this. So what we're going to have is negative I x3 equals x over 4. And then over here, I'm going to do the same thing. I'm going to move this over here. And this is going to be x3 equals I x over 4. And then, okay, for this one, let's solve it. Let's try to solve it. The way I did it was, okay, we have x over 3, which is equal to I x4. We know that this is going to be this because of this equation. So we're going to have x3 equals I times negative I. And we know that I times I equals negative 1. Since this is negative, it's going to be I times negative I. This is 1. So x3 will be equal to 1. And then, I'm sorry. And then since x3 equals to 1, I'm going to plug in right here for this equation to find x of 4. So x of 4 will equal to negative I, because x3 is 1. So this is x4. So for this equation, for this eigenvalue, for the eigenvalue of, which one was it? Sorry. 1 plus 2i, we have we have 0, 0, 3 is 1, and 4 is negative I. Now for the other one, it's going to be the same process, just a negative. And for this one, the only variable that's going to change, it's going to be I, which is going to be positive, I believe. Don't call me on that right now. And then let's try to do the next eigenvalue, which is the eigenvalue of 1 plus 5i. And we're going to do the same thing. We're going to do the formula. Oh my god. And then, so this is going to be 1 minus 1 plus 5i. And then it's going to be 5, 0, 0. Then negative 5. 1 minus 1 plus 5i. 0, 0. And it's going to be 0, 0. 1 minus 1 plus 5i. And then this is going to be 2. And then this is going to be 0, 0. No. Yeah. 0. Negative 2. 1 minus 1 plus 5i. And this is our equation with this eigenvector. Can I zoom out? Okay, not at the moment. I cannot zoom out. And this is going to be equal to 0, 0, 0, 0. Okay. Oh, why can't I zoom out? Okay, I think this is the largest way I can zoom out. So this is the equation that I have at the moment. Now I'm gonna solve it. Let me get my calculator. Okay. This is okay, give me a second. This is gonna be negative 5i. And since this is gonna be the same for each one, so it's negative 5i, 5, 0, 0. Let's make this this bit smaller. It's gonna be 5, and it's gonna be negative 5i. Be 0, 0. It's gonna be 0, 0, negative 5i, and then 2, then 0, 0, then negative 2, and then negative 5i. And this is gonna be equal to 0. So we're able to find our eigenvectors. Okay, from there, let's try and use also let's find the equations again. So it's gonna be negative 5i x1 minus 5 x2. I'm sorry. And this is gonna be 5x1 minus xi x2. It's gonna be equal to 0, 0. And then this is gonna be, the other one is gonna be negative 5i minus 2. And this 2, this is x3, this is x4 equals to 0. And this is gonna be 2x3 minus 5i x4 equals to 0. Okay, from there, I'm going to be solving the first equation. Well, we see this 2 and it's going to be the same the same work as the first one, which was this 2. Maybe the same one. If you, I don't know if you can see it, but like the equations are going to be the same. Not the same, but like for x3, I'm going to have 2i over 5 x4. Then x3 equals 5i over 2 x4. Now for the first equation, this one, I will try to find the equation which is negative 1i x1 equals x2. And then for this one is x1 equals x2. We're going to do the same as the other equation. So this 2. So x3 equals to 0. x4 will equal to 0. Now for this one, it's going to be x1 equals to I x2. So we're going to try to find x1. So x1 equals to, we know that x2, it's equals to negative I. It's going to be I times negative I. So 1 will be 1. x1 will be 1. And then if we plug in x1 in here, we know that x2 will be negative I. Okay? So for the eigenvectors for this, for this equation, 5, 1 plus 5i, this is going to be 1, negative I, 0, 0. And if we do it for the same equation, 5i minus 5i, and we do the same process, this is, instead of a minus, it's going to be a positive. And this is going to be our eigenvectors. So hopefully this helped a bit. Sorry if you cannot see the whole paper. As you may see, I started small and then I ended up big. big letters. So we have our eigen values, which is 1 minus 2i, 1 plus 2i, 1 plus 1 plus 5i, then we have 1 minus 5i. This is our eigenvalues, and our eigenvectors will be okay, so I'm gonna be, so for this one, it's gonna be give me a second. For this one, it's gonna be 0, 0, 1 I T transpose. I'm gonna put it like, because when I put the transpose, this means that it's gonna be end up like this. Okay? And then for this one, it's gonna be 0, 0, 1, negative I transpose. And then for this one, it's gonna be 1, 1 I 0, 0. This is negative, sorry. Negative I. Oh my god. And then we have the last one, which is I minus 5I, which is going to be 1I 0 0. And this is going to be transpose, and this is going to be transpose. Hopefully this helped you on the homework or for studying. And hope this helped a lot. Thank you. Have a nice day. And have a nice evening, and take care of yourself.